Hello, my name is Suhan, student from SUTD Engineering Systems and Design, and I'll be showing you my project done for 40.015 Simulation Modeling and Analysis module. So the title of my project is a food delivery agent-based simulation model, which I do a comparison of waiting periods for different transport options in food delivery simulation, um, most prominently bicycle, car, and motorcycle deliveries. And I also do optimization of waiting periods using a dynamic pricing method. So just a simple introduction to my page. So it's a simple introduction, and this is a simulation space as well as various statistics used for the simulation, such as average delivery times for the different drivers and probability of different arrivals, as well as the pricing, the number of idle drivers and stuff. So this is where once I run my simulation, there'll be graphs to show certain various statistics as well. And this is some control panels that I'm able to do to change the simulation space. So without further ado, let me run the simulation first. So once a house obtains an order, you turn red color to indicate that it has received the food order. Then a vehicle will move to a shop, which is the yellow colored shop picture, and go to the house to deliver. So the red colored square will actually turn into pink. So in this simulation space, you see three different types of drivers. So one bicycle, one car, and one motorcycle drivers. So they have corresponding different types of speeds. So you see the motorcycle drivers moving very fast, whilst the car drivers move a bit slower than the motorcycle, and the bicycle drivers move much slower in comparison to the other types of vehicles. So in this simulation space, you are able to see the different drivers in action, and those in stationary are meant to show that they are in idle mode, waiting for an order to come in, which we are able to actually change it by the probability of order arrivals. So over here, we can see a big difference in the steady state average of the waiting times. So such as the bicycle, car, and motorcycle. So we'll have to run the simulation for longer periods to see, but we roughly see that the motorcycle drivers actually have a faster delivery time in comparison to the car and bicycle. And we also see the revenue generated per time period, in which soon we'll see it move down to a steady state average as well. So let me just quickly speed up the process here to actually show you the steady state average that will happen. So actually, the point of the results of this output analysis is that we clearly see the difference in waiting times, and many of us face this challenge where when we order GrabFood or Foodpanda in Singapore, we actually pay the same price, but um, the chances of us having a bicycle driver is more often than not higher than motorcycle or car drivers, in which the waiting times can actually vary very high. So the standard deviation of our waiting times may be much high, in which I believe that there could be further work done by delivery services to actually analyze how fairly the consumer can pay for our delivery services, okay, corresponding to the predicted waiting times for our food. And now we see that average revenue generated, we are moving to a steady state average, as well as the um, orders being processed per time, as well as the idle drivers are moving to a steady state average to produce a stable system. So evidently my system is actually comprised of many simplifications. There's no consideration of traffic kind of like circumstances or kind of things, but there's also been an attempt to simulate certain real space where maybe when the driver is collecting the food, there's a random distributed waiting time, as well as when the driver um, kind of drops off the food at the house, there's also the randomly distributed pickup time as well. And also there's been a mathematical um, development to produce a dynamic pricing algorithm to actually stabilize the system, which actually takes into account the weighted coefficients of a different average delivery times to the desired delivery times, as well as the number of idle drivers, revenue generated, and the number of orders being served to actually produce certain optimality in the system that I desired for. So actually that's the end. For more, if you have any questions regarding my model, or would like to know anything else about um, the extensions of this module, as well as this output analysis for this project, please don't hesitate to come talk to me. I'm Suhan from SUTD. So thank you very much.